Supplement problem number 1. Sarah leaves Seattle for New York in her car, averaging 80 miles per hour across open country. 1 hour later, a plane leaves Seattle for New York, following the same route and flying at 400 miles per hour. How long will it be before the plane overtakes the car? Okay, so let's visualize first the movement of a moving object, the car and the plane. Once we visualize it, we need to consider the data or the parameters in it. So Sarah using his car and the plane moves 1 hour later. So based on the movement, it is not stated in the problem, but it is said that they live at the same point in shuttle. Okay, so they live at the same point in shuttle, the car and the plane. They are moving in the same direction, going to their same destination, New York. Okay, so what is your observation here? So the car and the plane, though they travel at the same path, the car travels by the road and the plane by the air. So car is the rate of change of car is 80 miles per hour compared to our plane, which is flying at 400 miles per hour. Of course, plane moves faster compared to car. Now, what is our observation here? Okay, it's obvious that the distance from shuttle at a point in shuttle going to New York does not change. So we can say that the distance of the car traveled and the distance of the plane traveled are equal. Yes, so we can start with this. The distance of the car is equal to the distance of the plane. Okay, so the final question is how long will it be before the planes overtakes the car? Okay, so in order for us to formulate the equation easily, let's bring out our box. We call this our TRD box. Yes, the time rate distance box. But we'll make it 2 because we need to view a different approach. So okay, so let's make this 2 different approach, but they should have the same solution. Okay, so we let BRX, so we let X be our time in hour for the plane to travel same distance as car. Okay, that is our box number 1. So that would be our in our box number 1, we let X be our distance traveled. Okay, distance. So that be our X time traveled by the let X time in R for the plane to travel same distance as car. How about on the other side? Um, we let X time in R for car before plane overtakes it. Overtakes it. Okay. Okay, so let's formulate our equation. So we have the car and the data of our plane. Okay, now that we do, let's get the data. So we have our rate of change of our car is at 80 miles per hour, and the rate of change of our plane is 400 miles per hour. So for our car, this is 80 miles per hour, 80 miles per hour. For our plane, that is 400 miles per hour, 400 miles per hour. Okay, how about for x? Here in our first box, we let x time in hour for the plane to travel at the same distance as car. Okay, so we let x be our time in hour by the plane to travel at same distance with car. We all know that the distance from of our car is the same with the distance traveled by the plane. Okay, so we need to consider this 1 hour later. So of course the car moves ahead with the plane. Yes, 1 hour later, the plane leaves shuttle. So, of course, car consume more time. So, this is x plus 1. Okay, following our times rate distance formula, this will become 80 times the quantity x plus 1 on the plane, that is 400x. Okay, so here we can formulate our equation from this, right? Because they have equal distance. Now, solving for the x, formulating our equation, this is 80 times the quantity x plus 1 is equal to 400x. Solving for x, this will become 80x plus 80 is equal to 400x. Transpose 80x to the other side, that will become 320x. Therefore, our x is 80 over 320, or equal to 1/4. Okay, so 1/4 hour. So that is the time in hour for the plane to travel at the same distance as car. So of course, at that time, the plane will overtake the car. Okay, how about in our second box? We let x time in hour for the car before the plane overtakes it. Okay, so here we let x be the time of the car before the plane overtakes it. And the plane leaves 1 hour later. So, of course, since the car move ahead with the planes in advance, 1 hour advance, so therefore, the plane is width is lesser with 1 hour. Okay, so we can formulate our equation here. It will become 80x, applying our formula, and this will become 400 times the quantity x minus 1. Now, doing so from this formula again, since they have an equal distance, this will become 80x is equal to 400, the quantity x minus 1. So 80x, that will become 400x minus 400. We transpose negative 400 to the other side and 80x to the other side. So this will become 320x. Therefore, our x is 400 over 320. So this is equal to 400 divided 320. That will become 1 and 1/4 hour. But wait, the question here is how long will it be before the plane overtakes the car? So we apply this one. So doing so, that will become x minus 1, or equal to 1 and 1/4 minus 1, that is equal to 1/4 hour. So that is the time needed before the plane overtakes the car. So if you observe, the value of our unknown here, x, is same with the value of our x on our second solution. Okay, so let's recap. So more plus 1, less minus 1. Okay, so this one. So I hope you are clear with our solution. Okay, let's move to our next example.